You jump up and gravity brings you down to earth, as Newton said. All neat and tidy until Einstein came along with his general theory of relativity. Is gravity fake? Let's find out. Newton said gravity as a force between two bodies, which is given by the equation F equals g m1 m2 by r square, where g is the gravitational constant, m1 and m2 are the two masses, and r is the distance between them. This equation is still used and can give close to accurate results. Still, it fails in some situations. Like, according to the equation, a massless object should experience no force, right? See, light is a collection of massless particles called photons, and they should always follow straight path because no force acts upon them. Well, do you know that light doesn't always travel in a straight line and it will bend near massive objects like sun? Einstein proved the general theory of relativity by proving the bending of light near sun. We will discuss about it later in the video. Okay, now let's talk about general relativity. It describes gravity as a geometry. The fabric of the universe is full of lumps and bumps created by the presence of mass and energy. This warping is unavoidable, be it you, me, a space dust, or a photon. It tries to travel through a straight line. It actually follows a trajectory that is curved by any mass and energy in the vicinity. The result of this curvature is what we think of as gravity. Now let's get back to the experiment. If the positions of the stars near Sun could be precisely measured during an eclipse and then compared with their normal positions in the sky, and if these positions of the stars were altered in exactly the way that Einstein's theory predicted, then it should be because the gravity of the Sun caused a curvature in space and bended the light coming from the distant stars. Then this might be just the test general relativity needed. Eddington, who led the experiment, first measured the true positions of the stars during January and February 1990. Then in May, he went to the remote island of Principe to measure the stars' positions during the eclipse as viewed through the Sun's gravitational lens. Eddington found from the data that Einstein's predictions are confirmed. Einstein, until then a relatively obscure newcomer in theoretical physics, was then on the front page of major newspapers around the world. Dan Burns explained the space-time curvature in an interesting way. I have given the link to that video in my description. Check it out.